Figures 9.14 through 9.16, a subtle trap returning a reference to a private data member. In this example, we're going to look at a slimmed down version of the class time in which we're going to demonstrate the problems associated with returning references to private data. So in the example, we have our time class with our three private integers, hour, minute, and second. And of course, by making these private, what we're saying is that we want total control over those pieces of data, and that the client code should always have to go through our public interface to interact with that data. We have our time constructor to initialize a time object, our setTime member function to change the values in a time object, a getHour member function to return just the hour value, and also a function that we purposely called badSetHour, which, if you look at its return data type, is a reference to an integer. It's going to return a reference to a piece of integer data, and it will receive as its argument an integer to place into the hour data member. Now, let's take a look at our time CPP file, and you can see that the constructor is the same as it was in the previous time example. The setTime member function is changed to go back to explicitly validating the hour, minute, and second because we didn't provide separate setHour, setMinute, setSecond member functions in this example. GetHour simply returns the hour. And here is the key piece in this example, the badSetHour function, which receives an integer parameter representing the hour, validates whether the hour is greater than or equal to 0 and less than 24, and assigns the value to hour only if it's in range. Otherwise, we explicitly set it to 0. And then here is the piece you have to be aware of. When we say return hour here, we're saying to return the hour data member. Now, normally, if we just said int as the return type, that would say take a copy of the hour and return that copy, which means that the caller would not receive actual direct access to the hour piece of data. In this case, however, we're saying int ampersand as the return type, which indicates that this function returns a reference to an integer. A reference to an integer is an alias for that integer in memory. It gives you direct access to that piece of data. So in a way, what we're doing here is building a tunnel into this object from the outside that clients can use to directly manipulate the hour piece of data. Now let me show you how this could accidentally get used based on how we defined badSetHour in this example. So here we have our main function, which is going to work with this new version of the time class. We create a default time object t, and it's going to have zeros for the hour, minute, and second. Then at line 15, we say call t.badSetHour and set the hour to 20. Now 20, of course, is a valid hour in the range 0 to 23. And so that value is going to be set. And we're going to assign the returned reference to this integer reference variable called hourRef. Then at line 17, we're going to display the value that hourRef is currently referring to. We're going to change the value of this reference. And then we're going to tell the object to tell us what the hour is. So tell the object of type time called t to get its hour. Now I'm going to stop right there and run this program, and you'll see that initially the hour was 20. That's what hourRef is referring to. Then we assigned hourRef a new value, which was a value that was out of range, the value 30. And you can see here that t.getHour, which is saying go into the time object and give us the hour value, returned 30, which is an out of range value. So our time object is no longer in a consistent state. So right away we see one of the big problems with returning a reference to a private piece of data. You're giving the client code direct access to that piece of data. We'll come back to the rest of this output in a moment. Now, the interesting thing is that a member function that returns a reference, especially a non-constant reference, such a member function can be used as an L value on the left side of an assignment. So here at line 23, we have a call to t.badSetHour. This is going to set the hour to 12, representing midday, noon. And the reference that's being returned from this will then be used on the left side of this assignment to assign the value 74 to the hour piece of data, because remember, bad set hour returns a reference directly to the hour piece of data. So this is kind of a strange looking assignment statement, but the fact is that the member function call on the left side of the assignment is returning a reference, and references that are not declared constant can be used as L values. So we're here assigning to the hour data member first the value 12, then the value 74 using the reference that's returned, and now we output once again what t.getHour is returning to us, and you can see here that t.getHour returned the value 74, which once again is way out of range for a value of the hour inside of a time object. So when you are building member functions of your class, you have to carefully consider what you are returning from each member function. Now, normally set member functions don't return values at all, so the first step in our in fixing this problem here would be to simply change the return type of this function to void and not have a return statement in the body of the bad set hour member function. But for any other member function that does have to return a value, you need to consider whether you're going to return that value, by reference, or by reference via a pointer. And depending on what the item is that you're returning, you may have to think carefully about what you are actually doing there, because if you provide access to private data, that is basically breaking the encapsulation of your class. It's giving the client code direct access to data within your class that's supposed to be hidden from the client. If you have to change that data representation for some reason, then because the client code now has direct access, it's dependent on that data, and any changes to your class could result in the client code having to be rewritten. So you really want to be careful when you're designing a class, and specifically the member functions of your class, to make sure that whatever you're returning does not break your class's encapsulation. So in general, you'll typically return copies of things inside of the class, and in other cases, if you do need to return pointers or references, you'll often do so using const in front of the return type to ensure that the client code cannot modify what it's receiving directly.